Hi everyone, today we are going to talk about the topic of comparison of Apache Beam and Amazon Kinesis. In total, we are three members, Dhruvil Shah, Umang Sood, and Manoj Legar. So first, we'll talk about the primary objective is to provide variable insights for the ongoing address on processing frameworks, aiming to assist organization in making well-informed decisions regarding their data processing needs in particular of CPU and memory usage. To contribute this goal, we began with the London weather dataset, which initially comprised of 15,342 entries and 10 columns. Through pre-processing, we narrowed it down to three essential columns, which is date, maximum temperature, and minimum temperature, resulting in a dataset of 15,335, which removed null entries and redundant dates. Subsequently, we partitioned the data into three categories based on the volume, low, medium, and high. Our focus lies on evaluating the performance metrics, including the time taken for data processing, CPU utilization, and memory usage. By analyzing these aims, we aim to provide valuable insights to the industry in choosing the most suitable framework, considering aspects of both performance and scalability. Next, my colleague will talk about Apache Beam.
So, what is Apache Beam? Apache Beam is a powerful open source framework designed to facilitate the creation of both batch and streaming data processing pipelines. It provides developers with a unified model to write data processing code that can seamlessly run on various distributed processing backends, including Apache Flink, Apache Spark, and Google Cloud Dataflow. Now let's dive into setting up our environment and loading the dataset. We have set up Apache Beam GCP in our environment, enabling the installation of Apache Beam along with the additional dependencies needed to support Google Cloud Platform GCP. This configuration is crucial for conducting our testing seamlessly. We'll be using the preprocessed data.csv as our dataset to demonstrate Apache Beam's capability in handling and processing real-world data. During our experimentation, we encountered a challenge related to calculating CPU usage. The accuracy was inconsistent and not up to the mark. To resolve this, it's essential to ensure that the measurement of CPU usage is taken consistently and accurately. This might involve refining the method used to capture CPU metrics or exploring alternative approaches for more reliable results. Now let's define our experiment scenario. We'll work with our data set, randomly selecting subsets of 1,000 low volume data, 5,000 medium volume of data, and 15,000 entries, which is considered to be a high volume data. This will allow us to showcase Apache Beam's ability to handle different data volumes and processing requirements. For our final result, we saw that for 1,000 entries, average processing time was 23 milliseconds, CPU usage 21%, memory usage 63%. Scaling up to 5,000 entities, the average processing time rises to 93 milliseconds, CPU usage at 24%, and memory usage stays at 63%. For 15,000 entities, average processing time increases to 228 milliseconds, CPU usage drops to 17%, and memory usage slightly rises to 64%. It's interesting to note that as the number of entities increases, processing time also increases, but CPU usage shows variability without consistent patterns. Now, my colleague will continue with Amazon Kinesis.
Alternatively, Amazon Kinesis, which is a component part of Amazon Web Services, is used to store and analyze the real-time streaming data. To initiate our experiment, first we have to make the Amazon account, which will require you to put in all your banking information. Once the account has been created, we'll be creating a new IAM user, which is known as Identity and Access Management user, and allotting him a specific group. The group, we have to change the permissions so that the person which is assessing the group have all the necessary permissions to perform the experiment. Once the user and the group has been created and Kinesis stream is set up. In this experiment, we have named the Kinesis stream as Demo 12. The Kinesis stream will consist of all the important information such as the access key ID, the secret access key ID, and the region which we have to put it into the Python file to process the experiment. The data which has been pre-processed by my colleague is uploaded with the help of Boto3 library and Amazon KCLP library, which is known as Kinesis Client Library. Once the data has been uploaded to the Kinesis stream, a consumer application is developed. The experiment is performed on three different volumes of data to ensure that we have the controlled environment for the execution. We have the low volume of data, we have the medium volume of data, and we have the high volume of data. During recording the results of the data, a Prometheus library was earlier used, but facing numerous challenges on the same library, we have to change it and we used a logging library. As we know, this library helped us to make a systematic and secure environment for the execution of the environment. The final results for various inputs of data stands below. For the very initial phase, where we used 1000 entities, the model took around 0.003 seconds to perform the entire process, while as the CPU usage and the memory usage was 5.5% and 57% respectively. When it comes to the medium set of data consisting of 5,000 entities, the time taken was 0.016 seconds, while as the memory and the CPU usage was 57% and 56%. While coming to the high volume of data, which is around 15,000 entities, the total time taken was 0.00 seconds, while the CPU storage and the memory usage exceeded by 57.2% to 6.3%. Next, my colleague will be explaining the whole results.
To conclude, the line graph compares the processing time between Apache Beam and Amazon Kinesis. The time taken for Apache Beam is more than Amazon Kinesis, and the grouped bar graph compares that Apache Beam consumes more memory than Amazon Kinesis for different data volumes. Overall, Amazon Kinesis is better than Apache Beam. However, Amazon Kinesis is expensive because it asks the user to pay $0.015 per data entry, and Apache Beam is open source. Thank you, everyone.